section 4.4, which is on one type of function called radical functions. And you can kind of see what I did there with the font. I did like if there was a font called rad, I think that's what it would look like. It's pretty cool, huh?
Yeah.
It's cool. So radical functions are basically any type of function that has a root in it. So we could be talking specifically about square roots, but not just square roots, there's cube roots, there's other types of roots. And here's a couple examples. Oops. So one of them, let's see if I can move that up for you. There you go. Y equals the square root of x minus 2. That's a square root. We'll talk more about how you know it's a square root, but that's a square root. The second one is a cube root. Y equals the cube root of x squared minus 1 plus x. So those are both examples of the types of things we're going to be working with today.
Wait, isn't the first one a square root because you can't do a negative and square root is negative?
The first one is a square root.
Yeah.
Yes. Yep. Sorry, so what was that your question? Just that it was a square root?
Yeah, but isn't it like one because you can't take the square root of a negative?
Correct. You can't take the square root of a negative. We'll talk about that. Yep. Square roots, when you're dealing with an even root, you have to be careful about certain things. Odd roots, you really don't have to be as careful. Okay, by even roots, there are certain things we don't want to do, like taking the square root of a negative. So basically, anything that has this type of thing in it is what we call a radical expression. A radical expression. That little number has a name that you put on the outside of that square root symbol, or the outside of the radical symbol. I'll tell you what that is in a minute. But for now, I'll tell you that that number has to be an integer, and it has to be greater than 1. So you never see this symbol with like a decimal right there. You can't. That doesn't exist. So you could do a cube root, or you could do a fourth root, but there's nothing in between a cube root and a fourth root. There's no 3.6 or anything like that. And this number also can't be a negative. The smallest that it can be is a 2. Then it can go up from there without any fractions or decimals. So 3, 4, 5, 6. Okay, so this thing that I have circled is called a radical. And here's another example. Let's see, square root of 13. That's a radical. It's not an equation because it doesn't have an equal sign. It's just a radical. If you do something like that, you put in an equation and you put in a variable, now it's, or you put in an equal sign, now it's an equation that you could solve for x. This number, I guess I should make this a lowercase technically. But that number that you put on the outside of the radical symbol, that's called the index. The index just tells you what kind of root you're doing. Is it a square root? Is it a cube root? What kind of root is it? And I'll show you on the calculator how you can type in these different roots. The most common root is a square root, and there's a button for that. But if you want to do roots other than that one, you need to type it in a certain way. The thing that is underneath the radical symbol, that's called the radicand. It's what, like for example, if you have the square root of 13, 13 is called the radicand. It's the thing you're taking the root of. In this case, it's square root of 13. Okay, but whatever is underneath the radical sign, that's called the radicand. And then the actual symbol itself that has, it looks kind of like a check mark with the horizontal line, that's called a radical symbol. Right, so those are some of the words we're going to see when we talk about radicals. Any questions on any of those terms I have underlined? All right, so how do you type in, yes?
Sorry, what is the definition of radicand?
The radicand is the expression that's under the radical symbol, or under the radical sign, you could say it that way. Radical symbol, radical sign, it's the same thing. It's whatever's underneath it. All right, so let me show you how you do a square root. So if you want to do a square root, there's a button. You press second, x squared, and then you can put in your radicand, and we get an answer of 4. Now, if you want to do a cube root or anything higher, this is how you do it. The first thing you have to type in is the index. Okay, so we're going to put in a 3. And then we have to go to the math menu. Under the math menu is where you can put in roots other than square roots. So you put in your index, then you press math. When you press math, you're going to get a list of different options. The 5th one down has an x in place of the radicand. So it's going to take whatever number is already put in on the calculator before you went to the screen, and it's going to use that as the index. So I put in a 3. So if I go back here and pick option 5, it just changed that 3 that I had put in to be the index. So you put in your index, then you go math, option 5, and then you can put in your radicand, whatever you want to put in. Let's say you want to do the cube root of 27, and you get an answer of 3. So any question on how to type that in? Yeah?
Did you also use the 4 on the pad?
So for cube root, there is an option for that in this menu. So you could use option 4 for a cube root. But the option I showed you, you could do any root. Because there is no other option other than cube root here. Like if you had to do a 5th root, there's no option for it. If you see a radical symbol or radical sign, and there is no index, we always assume that it's a 2. That is the symbol for a square root. Technically, I guess you could put a 2 right there for the index. I've never really seen it written that way, but you could. So if there's no index, we always assume it's a 2. Now, there's a connection between typing something in with a radical sign and an exponent. If you didn't have, let's say you didn't have a button on your calculator to do 5th roots. You don't need this button. You don't need that option 5. You can type in a 5th root on the calculator with an exponent instead. Let me show you how that works. If you wanted to take the square root of something, and for some reason your calculator didn't have a square root button, but you could do exponents, that'd be pretty weird, but if that happened, you can type in a square root as an exponent of 1/2. That number that I just circled is the index from your radical. So a square root is the same as raising to the 1/2 power. Let's try it. So if I take 36 and raise it to the 1/2 power, it's going to take the square root of 36. So what should I get when I hit enter? Yeah, 6. And I do. Raising something to the 1/2 power is exactly the same as taking a square root. So what power do you think would be the same? Well, never mind. Well, 1/3 is the same as a cube root. How about if I had, like, let's say I wanted to do the 4th root. What exponent do you think would be the same as doing a fourth root? Yep.
1/4.
1/4. Yeah. And let's look at this one. This is the fifth root of x to the fourth. So what exponent do you think is the same as a fifth root? Yeah?
1/5.
1/5. This is why you would sometimes change it to an exponent. Because if you want to take the fifth root of x to the fourth, that means to raise x to the fourth to the 1/5 power. So now you have x to the fourth to the 1/5. That's a power to a power. What happens when you have a power raised to a power? What do you do with the two powers? Yep. You multiply them. So 4 times 1/5 is 4/5. So the reason why we might change something that's a radical into an exponent is if you ever end up with a power to a power, then you can simplify it. That's why we might do it. Would you ever really do like one like this? I mean, probably not. There's no real reason to do that in general. But this last one, definitely useful. So, any question on how to change something from a radical to a power? Okay, so let's talk about another term that means principal, what's called principal root. When you're solving an equation that has a root in it, there are as many answers as the index. For example, if I wanted to find the square root of 4, how many answers are there when you take the square root of 4? How many different answers? Yeah? There's 2 answers. 2 times 2 is 4. -2 times -2 is also 4. If the question specifically says to find a principal root, they want 1 answer. So which answer would you give me? 2 or the -2? Well, it depends on whether your equation is even, whether your index is even or odd. Even's a little trickier because we got to be careful with taking roots of negatives, right? So with evens, in general, we're going to look for the positive answer. But with odds, the answer could be anything. Could be positive or negative. This is how you find the principal root if you're dealing with an index that's odd. And if you're like, well, wait, what do you mean? Solve this equation. Let's say that I was talking to somebody that doesn't understand what a cube root is. Right? They said, I don't know what you mean. You want me to find the cube root of 27. I don't understand what cube root means. Well, I would say, to find the cube root of a number, you're trying to find what times itself 3 times gives you that number. So I would say, there's some number times itself 3 times that will give you, I don't remember what I said, whatever you're looking for. So if you don't understand how to find the cube root of 64, this is the equation I would say to set up. What number times itself 3 times gives you 64? And then to solve that, you've got an exponent of 3. To get rid of an exponent of 3, we take a cube root. So x equals the cube root of 64. So the answer there would be 4. And in this case, 4 is what we call the principal root. You just solve that equation, and the number that you get is the principal root. Now, the number that's under here, the radicand, 64, could be a positive or a negative. You can do cube roots of positives or negatives, and that's not a problem. Yeah?
So the principal root is the real solution, right?
Yeah, we don't want any imaginary solutions. Okay. Yeah.
So could you apply that concept to like a specific problem? Because I think I understand what you're doing, but I don't. Like, would x cubed equals 64 be your original problem, or are you deriving it from something else?
No, you could have something just like that, and then you just take the cube root of both sides, and then the answer is what you call the principal root. So you've probably solved equations like that before. I don't know if you've ever called the answer the principal root, but if it asks you for the principal root, that's what they're asking you to do.
So why is it 4 and not 4 comma negative 4?
Why is it 4 and not what?
4 and negative 4.
Because negative 4 times negative 4 times negative 4 is negative 64.
Okay.
The other two, because this is a cube root, so I said to you that there's always as many answers as there are roots. The other two answers when you do a cube root are imaginary. So we're not talking about the imaginary answers because those are not what we call the principal root. All right. Now, if n is even, well, first of all, if n is even, a couple things have to happen. You cannot take an even root of a negative number and get a real answer. So first of all, whatever we're going to take the root of has to be at least 0 or higher. And when we write our answer, we're looking for the answer that's not negative. So let's try one like this. All right, so let's say again, I was talking to somebody that said, I don't understand what you mean when you say take a square root. I don't understand square root. I would say, okay, square root means that there's a number times itself that will give you the number you want. So let's say you wanted to find the square root of 49. I would say that there's some number times itself that will give you 49. Something times itself equals 49. That number that I just circled has to be greater than or equal to 0. Because if it wasn't, what we're about to do in the next step would be a problem. How do you get rid of an exponent of 2? Yep. You take the square root on both sides. Well, we just said earlier you can't take the square root of a negative. So if 49 was a negative, now we would be getting into imaginary numbers, and that's not what we want to do in this section. So we're good. 49 is positive. We can take the square root of 49. There are two answers. What times what gives you 49? Yeah? 7 and? Negative 7. But if they want the principal root, they want one answer, and they want the one that's not negative. They want positive. So the answer to this problem would be just 7. Don't worry about negative 7. So any questions on that idea? So principal root is just a way of saying when you're solving a root problem, give me one answer. And it's a way of all agreeing on which one answer are you going to get. For even roots, always give me the positive answer. And for odd roots, always give me the real answer. I never want an imaginary answer. Now, can you take, I already kind of mentioned this, but can you do the cube root of negative 64? Is it okay to have a negative underneath there? Definitely?
Yeah.
Why? I thought we just said you can't have negatives under the symbol.
That's only for square roots.
That's only for, can you be a little more general? Yeah?
Evens.
It's only for even roots that you can't have a negative under here. That's not an even root. That's a cube root. So the answer to this problem would be negative 4. All right. So now let's take a look at specifically just a square root. And I want to know what happens when you take square roots. I want to see, does the number get smaller or does it get larger? And you see what I did there? So smaller is smaller font, and larger is larger font.
It's so creative.
I'm on fire today, huh? All right. So here's a number on the left, and I want you to tell me the square root of the number on the right. So let's start with 4. What's the square root of 4? 2. Yes, it's also -2, but we're dealing with the principal root, so one answer. Okay, did it get smaller or larger?
Smaller.
Okay, that time it got smaller. Let's try the square root of 18. Okay, square root of 18. 4.2, roughly. Smaller or larger? Smaller. Okay, so it looks like when you take square roots, the answer, it gets smaller. Well, let's try 1. What's the square root of 1? 1. So maybe when you take square roots, it either stays the same or gets smaller. Well, let's try the square root of 0.5. Square root of 0.5 is 0.71. What happened that time? It got larger. And if we do the square root of 0.2, that is also going to get larger. It's about 0.45. So the answer as to whether a square root gets smaller or larger, well, it depends. Depends on what number you're taking the square root of. What number do you think is kind of the boundary between taking a square root and it getting smaller or larger? Yeah?
0.
No, not 0. Yeah?
1.
1. If your number is bigger than 1 and you take the square root, it will get smaller. If your number is less than 1, but it can't be negative because we're not talking about negative square roots. But if it's between 0 and 1, it will get larger. Okay, so 1 is kind of the division line. So let's graph a square root so you can see what it looks like. Square root of x. And I'll do 4th root of x at the same time. Okay, so I'm going to graph square root and 4th root. Put this here. Go like that. Okay, first of all, do these graphs go in both directions or just one direction? Yeah, even roots only go in one direction because they can't go negative. If I zoom in on quadrant 1 a little bit, so now we know it doesn't go outside of quadrant 1. So let's set that to 0 and set that to 0. Let's graph it again. This time it'll be a little bigger. You kind of see something that's happening. I think you can see it a little better in this one. But if you look at it closely, the blue graph is above the red one most of the time, except when you're between 0 and 1. Then the blue graph is underneath. That's how roots work. So both of these roots look like they go through what coordinate? Yeah?
0, 0.
Yep, they both go through 0, 0, because the square root of 0 is 0, and the 4th root of 0 is 0. So they both go through 0, 0. But there's one other one. Yeah?
I don't know if that first line is 1.
Yeah, these are all going by ones. Yep.
Okay, so 1,
1, 1. So 0, 0 and 1, 1 are points that are common to all even roots. And you say, well, wait, what if we've talked about like moving something left and right, like shifting it? Well, yes, if you shift it, then no, these points would not be the same. But if you don't shift it or stretch it or do anything to it, and just graph the basic function, all even roots go through those 2 points. 6th root, 8th root, 10th root, they all go through those 2 points. Yeah?
What are indices?
That's the type of root you're taking. It's the plural of index.
Oh, okay.
So indice is just the plural of the index. Now, domain, well, I asked you guys earlier, does it go in one direction or does it go in both? It only goes from 0 to the right. So that's the domain, 0 to infinity, including 0. And the range is also 0 to infinity. It might look like this root is leveling off, but it never does. It slowly just keeps going up. If you want to kind of visualize what a square root function is, it's a parabola on its side. That's a square root function. It's actually just half a parabola on its side. And the parabola never stops. Like if you drew the other half in down here, the parabola never stops getting wider. Right? So it's going to keep going up. So that's even. So a few things about even roots. Let's look at a few things about odd roots. So let me put in cube root. And let's do a fifth root. So these are odd roots. Now, when you take an odd root, can you take an odd root of a positive number? Yeah. Can you do an odd root of a negative number? Yes. So you can do odds and you can do you can do positives and you can do negatives. So what that means is, you need an X there. This type of graph goes left and right. It goes both ways. Right, so there's an odd root. That's a cube root. And there's a fifth root. Now, I need to zoom in a little bit so you can see kind of what's happening near the origin. But the point is it does go both ways. So what does that mean the domain is going to be for odd roots? Yep.
Negative infinity to infinity.
Yep. Negative infinity to infinity. It's all real numbers. And how about the range? Yep.
Also negative infinity to infinity.
Right, the range is also negative infinity to infinity. These graphs will slowly just keep going up and down forever. All right, let's set the y max and min a little bit closer. Let's do like -4. So I'm going to zoom in a little bit. Still a little hard to see. And these should be connected, even though it looks like they kind of skip a little bit. They are connected. Just the calculator can't draw it perfect. Does anybody think they see a coordinate where those two graphs cross? Yep.
0, 0.
Yeah, they do cross at 0, 0. Yep.
-1,
-1. Yep. And yep, 1, 1, 1. So odd roots have 3 points that are common to all of them. Again, what if you took a problem and you shifted it left or right? Well then no. You're going to shift these 3 points left and right. Domain and range for odd roots is all real numbers. So the nice thing about that is no matter how you shift or stretch an odd root graph, the domain and the range never changes. Right. Let's look at transformations. The nice thing about the transformations is everything is exactly the same. as every transformation we've studied all year. There are 4 general transformations. 2 of them are stretches. 2 of them are shifts. The order that you would do them in is indicated by the letters A, B, C, D. You do A first, then B, then C, then D would be last. Let's go through, and even though these transformations are similar to the transformations, not even similar, they're identical to everything we've done before, let's just label which ones are which. Does anyone remember when you add or subtract inside your function? In this case, inside means under the root. What does adding or subtracting close to the x value do? Manny?
Horizontal.
That's your horizontal shift. And remember, positive is going to move you which way? Yep. Well, positive is going to move you left. And negative is to the right. Okay, so that's A. Now B is still inside. It's still close to the x, but it's multiplication instead of addition. So it's going to have something in common with the one we just did, because it's still close to the x. But now it's multiplication. So anybody remember what B does? Yeah?
It's a horizontal stretch.
Yep. That's your horizontal stretch. Now we're getting to the ones that are away from the x. So we're done with horizontals. C is on the outside, but it's multiplication. So think about what multiplication did before, but now you're on the outside instead of the inside. Yep.
So vertical stretch.
That's your vertical stretch. And put it over here, D. Now you're adding, could be subtracting, but you're on the outside. So what is adding or subtracting away from the x value on the outside? Yes? That's your vertical shift. And can you tell me which way is up? Positive is up, and negative is down. What else? What if C or B was negative? Anybody remember what the negative does? Yeah?
You shrink.
So whether it's a stretch or a shrink is controlled by whether the number is bigger than 1 or less than 1. But a negative would do something different. Yeah?
It would flip the entire thing.
It would flip it. So if B is negative, you would get a horizontal reflection. That would look something like this. That's a horizontal reflection. You could also say reflect over the y-axis. If C was negative, that would be a vertical reflection. That would be over the x-axis. So there's really up to 6 things that could happen. 2 stretches, 2 shifts, 2 reflections. And I generally don't give you a problem with like 6 of them in the same problem. You may have 2 or 3. This one only has 1. So let's describe it. All right, so to sketch the square root of x minus 2. Can anybody tell me what the one transformation is you would have to do, starting from this one, to get that one?
Shift right too.
Shift, let's see, it is a horizontal and it's negative, so that's to the right. Yep. So to sketch that, you would shift the square root of x. Right 2. That's all you have to do. All right, let's try this one. So to sketch square root of x plus 3, what would you have to do to the square root of x? Take it, shift it, stretch it, flip it. Yep.
Horizontal shift left 3 units.
So shift square root of x, left 3. Okay, let's look at this one. Now, the last one, k of x equals 3 minus x, it's not written kind of the right way. You should always write it so that the number with x is first, and then the number without x is last. So, could someone just tell me how to fix that? So that x is first, and the number without x is last. Next.
Maybe a negative x plus 3.
Yep, negative x plus 3. Good. How many transformations are happening in this problem? 2. So to sketch square root of 3 minus x, oh, I'm sorry, we fixed that. Negative x plus 3. What's the first thing that you would do? Now you have to pay attention to the A, B, C, D. The order here is very important. What's the first thing? Yeah, Caleb?
Horizontal shift left 3.
So shift left 3. Yep, I like that. And the second thing you would do, you can say it a couple different ways. Yep.
Reflection over the y-axis.
Reflect over the y-axis. Or you could have said horizontal reflection.
Please excuse the interruption.
Okay, so we talked about even functions and odd functions. Which type of function or which type of root was the one that only went in one direction? Even or odd? Yeah?
Even.
Even. Okay, the odds, those go both directions. Either way, and I call these two different things. You want to find the point that would have been at the origin. If it's an even function, I call the point that would have been at the origin the start point, because it starts there and then it goes in one direction. If it's an odd function, the point that would have been at the origin, I call that the center point. So for an even function, it's a start point. For an odd function, it would have been what's right in the middle, the center. Either way, we want to find that point first. So to find that point, all you have to do is look at this. The C and the D, they don't matter for this. Just look at what's under the radical. Okay? That's the radical. Take that, set it equal to 0, and that will give you the x value of your new point. So set the radicand equal to 0, and that'll give you the x value. Once you have the x value, you're going to have a formula like that. Well, if you have the x value, all you have to do is fill it back in, do it out, and that'll give you the y value. So once you get the x value, substitute that number back into the formula to get your y value. Now, that point by itself, that's not enough. Okay, yes, you need that point. But you also need some points to the left and to the right of it, right? If it's the center. So you're going to want to get a few more points like that, so you can make your sketch. Or if it only curves in one direction, then we're only going to look for points in one direction. You're not going to have to do both. And to do this, we're going to use the table on the calculator. We'll try one sketch. The last thing is solving equations. We might get to one of those. If not, we'll do it tomorrow. All right, so first step. To find the x value of the center or the start. First, can you tell me, is this going to have a center or a start point? It's a cube root. It's going to have a center. So let's find the center. Set the radicand equal to 0. My radicand is 3 minus 2x. Set it equal to 0. And this will give you the x value of the center. And we get x equals about 1.5. Okay, I'm going to do it as a decimal because we're going to graph, and decimals are easier to graph than fractions. Now, what do I do with that 1.5 to get my y value? Yep. Yep.
Is that when you do the substitution?
Yeah, that's when we do the substitution. We're gonna plug it back in. So plug 1.5 in for x and tell me what y is. What's 2 times 1.5? From setting the radicand equal to 0. Yep. 3. What's 3 minus 3? 0. We already knew that would happen because we got 1.5 from setting it equal to 0, so it should be 0. So we get 0. What's the cube root of 0? Yep. 0 times 2? 0 plus 1. That's basically your y value every time. So there's the center. 1.5 comma 1. Now we want to get a few other points, and we could do it just like we did 1.5. We could just plug numbers in one at a time and do it out, but it's going to be faster if we use the table. So let's use the table. All right, so to use the table, first thing I have to do is type that in. Okay. All right, so let's clear out anything else that's in there. And I need 2 times the cube root. Okay, you pretty much type it in exactly the way you read it. 2 times, put in your index, math 5. So 2 times the cube root of 3 minus 2x plus 1. One thing that I like to do is when I go to the table, let's check the point we already found. 1.5 comma 1. So if I put in 1.5, I don't know if you can see it, but it is 1.51. So that just confirms what we did is already correct. Now, this is an odd root, so this is a center point. You need points on each side. I would say maybe 3 on each side. And when I say side, I mean to the left of the center and to the right of the center. So let's start with 3 numbers smaller than 1.5. 0 is good. I would say -4, -8. And now pick 3 numbers bigger than 1.5. 4, 8, 10. I just picked them random. Okay, so you can pick whatever you want. Try to space them out a little bit. So there's our points. And now we need something to graph on. All right, so start with the center. So that's at 1.5. What is it? 1.5, 1. Okay, let's do 0, a little below 4. -4, we're at positive 5.5 roughly. 2, 3, 4, 2, 3, 4, 5. And -8, we're a little bit above 6. 1, 2, 3, 4, 5, 6. All Right, so I can see the curve pretty good on that side. Now let's do the other side. 4, negative 2.5 roughly. 8, negative 3.7. Okay. 8 to 3.7. And 10, negative, a little more than negative 4. Yeah, that's pretty good. And there's my curve for my cubic. That's how you sketch a root. Now, if it was an even root, that would actually be a little bit easier because you'd have a start point, and then you'd only have to get a few points going in one direction. You wouldn't need points going the other way. If you accidentally pick a point going the wrong way on a graph that only curves one way, the calculator is going to say error because it's going to be trying to take the square root of a negative, and that won't work. Any question on sketching that root? Well, we could do another one tomorrow, because that's all we're doing tomorrow is reviewing this. I'm not going to sketch this one, but would this have a start point or a center point? Sam?
Center.
Why?
No, that's the center point, start point.
Start point, why?
Because it's even.
Yeah, it's going to be an even root, so it's only going to curve one way. Normally it would curve to the right, but I see a negative in front of that x, so I know that negative is going to cause a flip. So it's probably going to curve to the left somehow. Again, I have to figure it out with the table to get it exact, but that's the idea here. This one will curve left. All right, and yeah, last thing. So solving an equation. Probably have time for one of them, and then we'll do a second one tomorrow. When you want to solve a radical, the first thing is you have to get the radical by itself on one side. If you had a problem like square root of x plus 3 equals 10, the radical in that problem is not isolated. It has something next to it. The first step is to get that 3 on the other side by subtracting. That would be your first step. And then, to get rid of the radical, you have to raise each side to a power. What power you use depends on the root you want to get rid of. If you want to get rid of a square root, what would you raise each side to? Yep.
By the power of 2.
Power of 2. I would square each side, and I would get, in this case, x equals 49. And that's how you solve it. I'm not going to look at that right now. One thing we do have to check for, though, is our answer and make sure that it works. Because sometimes when you raise each side to a power, you get an answer that doesn't work. So we're not going to do the twice thing. I'm going to do the once thing with you. Yep.
Yeah, I'm going to ask, like, how would you do twice?
Twice only happens when you have a square root. They have 2 of them in the problem. I'm not going to do a 2 today. You're not going to have one in the homework either. And again, big thing here is check your answer. You have to check it. If you don't check it, you might end up getting partial credit. Let's look at this one. In this problem, is the cube root by itself on the left? Yeah, there's nothing like plus 6 that I need to move to the other side. It's by itself. So, how do you get rid of a cube root? What power would you use? Yep. We're going to raise each side to the third power. That's going to give me x squared minus 2x plus 2 equals x cubed. Now, do I have any like terms in that whole thing? Man?
No.
No. So, when you don't have any like terms, and you have 4 different ones, only way you can solve a problem that has 4 different terms in it is factor by grouping. It's the only way it's going to work out nice. To do factor by grouping, what number do you want to get, or actually when you do any kind of factoring, what number do you want on one side? Yep.
0.
0. I'm going to move everything to the right. I always like the highest term to be positive. That's why I didn't just move that one to the left. To me, it's easier. So x cubed minus x squared plus 2x minus 2. Now, what do the first two have in common that I could factor out? Yeah?
X squared.
X squared. Let's try it. Now the goal is that I get x minus 1 again. That's the only way factor by grouping works. What could I factor out of 2x and 2? Yeah?
2.
Just the 2. And if you factor a 2 out of 2x, you're left with x. And factor a 2 out of 2, perfect. You're left with x minus 1. Now, what do those two things have in common? Yep.
X minus 1.
Yep. So now we're going to factor that out. If you factor that out, what's left from the first line? Yep.
X to the second.
X to the second. And if you factor that out, what's left in the second one? Yep.
2.
The 2. So now, I would need to know what I would plug into both of these to make it equal to 0. So set that first one equal to 0. And set the second one equal to 0. Don't worry about the second one, because what's going to happen there? Yeah?
You're going to have to take the square root of the negative.
You're going to end up with a square root of negative. So in this particular problem, that part of the problem doesn't help me at all. This one does. What do I get? 1. Now, normally I would check that and make sure it works, but it does. You could go back and check it, and it works. So factor by grouping is going to come up. Regular factoring will come up, and maybe a quadratic formula. We'll see. Bless you. Okay, let me just adjust that. Okay, we would have had exactly enough time to do one more, but I figured something may interrupt us today. Okay, you don't have to do 35. So just those nine questions on page 255.